Alright, this is a new chapter which is called Locus. So I want you to put your name in the top left corner. Underneath that, put geometry. And underneath that, put down period 9. And then on the right side, we're going to put the date, which is 03/04/2013. Underneath that, you're going to put my name. And underneath that, you're going to put Locus. Okay, that's the name of the chapter. And then leave us some space and put L-01. Okay, this is lesson 1 of Locus. So, the first thing, locus means a set or bunch of points. Okay? A locus is a set of points that which satisfies a certain condition. Okay. Then skip a line and write this down. Think of a locus as a bunch of points that all do the same thing. Okay? The plural of locus is loci. L-O-C-I. Just like the plural of radius is radii. Okay? There are 5 basic locus theorems or rules. Okay? Now we're going to write down the steps to solving a locus problem. Number 1, draw a diagram showing the given lines and points. That's the first step. Second step, read carefully to determine the needed conditions. The needed condition or conditions, so we'll put it like that because sometimes there's one and sometimes there's more than one. Third rule, or third step, locate one point that satisfies the needed condition and plot it on your diagram. Period. Locate several additional points that satisfy the condition and plot them as well. Okay? Plot enough points so that a pattern or a shape or a path is starting to appear. Okay. 4. If you run out of space, just go on to the back. Okay. So 4 is through these plotted points. Draw a dotted line. To indicate the locus. Or path of the points. Number 5, describe in words the geometric path that appears to be I'm going to take this onto the back. You never write on the last line, by the way. That appears to be the locus, and I'm indenting a little bit just like where I left off, right? See how I was indented? That appears to be the locus. Skip a line. And the last step, number 6. If 2 conditions exist in your problem, let's put if 2 or more in parentheses conditions exist in your problem, which is called a compound locus. We'll do plenty of those problems. Repeat steps 2 through 4 above for all the conditions on the same diagram. Count the number of points where the two loci, now count the number of points where the loci intersect, because there could be two or more, so we'll just put loci intersect, period. In other words, in parentheses, let's put where do the dotted lines cross, and you'll see what I mean by that. Okay. Now, let's put that page aside for now. I need you to take out another sheet of loose leaf and re-put your heading, same as the last page. Okay. Now, at the top left, this is locus theorem 1. The locus of points at a fixed distance r, we'll just call it r, you can call it whatever variable you want, but we're going to name it r. So the locus of points at a fixed distance r from point P, and point P can be any point, is a circle with the given point P as its center and R as its radius. Okay? And here's what I want you to do. Let's see. Count down 1, 2, 3, 4, 5 lines and make a dot somewhere close to the middle of your page. Alright? Take out your compass and I want you to put, and you see you have two sides of this ruler, right? There's inches on the bottom and then there's centimeters on top. Okay? I want you to put this arrow, this first arrow, on the 1 inch. Line, right on the 1 inch line. So now the tip of that arrow is right on the 1 inch line. Okay? So what I'm going to do is I'm going to draw a 1 inch circle, a 1 inch radius circle around this point. Okay? And I want you to do it very lightly. Alright, because you're going to need to erase some of this line when you're done. So do a 1 inch circle. Okay? In fact, you can just do it, you don't have to worry about doing it lightly. You could do it nice and dark like that. And draw, use a straight edge to draw a line to the edge. It doesn't matter where, to what part of the edge. Draw a radius. So point P is the center of our circle, and point R is the radius. So that's a diagram for that theorem. Okay? Now, just give me 1 second here. Okay. So now I want you to think about this. Consider. Let's call it consider. Okay? You are standing in the middle of your classroom. Okay? Period. The teacher asks Spencer your classmate to stand 5 feet away from you. Okay? I then ask, let's see, Dulce, Liam, and Chris to also stand 5 feet away from you. Okay? Can you start to picture what is happening? If all of your classmates were to stand five feet away from you, what geometric shape or path would your classmates be forming? Okay? So I want you to imagine this, right? You're standing in the middle of your class, and I tell students to start standing around you 5 feet away from you. Okay? First 1, then 2, then 3, until the whole entire class is standing 5 feet away from you. Can you picture what's happening? Okay? Let's draw a little picture to demonstrate what's going on here. So let's say this dot is you. Alright, let's say this first dot up here is the first person I asked to stand 5 feet away from you. Let's say this is Spencer. Okay, and this distance, by the way, is 5 feet. And then I also asked what? I asked Dulce, Liam, and Chris to also stand 5 feet from you. Well, let's say Dulce decided to go here, and let's say Chris decided to go here. Alright, and let's say Liam decided to stand over here. All of these distances, by the way, are 5 feet away from you. Okay? 5 feet. These are all 5 feet distances. Then I say the rest of the class to get up and stand 5 feet away from you. Can you see what's going to happen? What shape is going to be formed as more and more students begin to stand 5 feet away from you? Okay? Hopefully now you see that what would happen is you would form a circle. Okay? This is an example of this theorem. Okay? You see how this is a set of points? If I kept adding more and more and more and more points forever, eventually what I would have is a circle. So the reason why they call these problems locus problems is because it starts as just a set of points, and then you keep making more and more and more and more and more points until eventually what you'll have is actually in this theorem, a circle. Okay? So locus theorem 1 identifies a circle at a fixed distance from a center point. Okay? In this problem, the radius was 5 feet. Okay? So, let's do some practice problems with this theorem. Okay. If you ran out of space, you could just, of course, write on the back. But now we're going to use a new sheet. Okay, this time you need a sheet of graph paper, which should have. Okay. Now I want the same deal at the top. I want your name. Course. And the period. Date. Then I want my name. And then locus L01. Okay? So, here's example 1. When he is not in the house, Fido is tied to a stake in the backyard. His leash attached to a stake is 15 feet long. When traveling at the end of his leash, What is the locus of Fido's path? Okay, that's our question. So let's solve it. Give me one sec. Okay. So it's 15 feet long is his leash. Okay, he's attached to a stake. His leash is 15 feet long. So what I want you to do is go about 5 places down in the middle and make a dot. Okay, and I want you to go 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 down. Let's make arrows, and let's go 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 to the right, and make arrows. Okay, now listen, this thing is 15 feet long, so this point right here is the stake, right? Now let's say that each box in this problem is 5. So 5 to the right would be one box, 5 up, -5, and -5. Okay? So instead of going by 1s, we're going by 5s here because we got to go to 15, so we're not going to go by 1s. That would be too big. So we'll go by 5s. So he's tied to a stake in the backyard. His leash is 15 feet long. So if I start from the stake, I go 5, 10, 15. So here's one point. This is as far as he can go up, right? Then I go 5, 10, 15. This is as far as he can go down. 5, 10, 15. This is as far as he can go to the right. 5, 10, 15. That's as far as he can go to the left. Now, he can also go at an angle. Right, he can go 15 feet in between all of these things, which would be right about in these positions. Right, and he can also go 15 feet in between all those. Okay, and he can go 15 feet everywhere. So essentially, the point of this problem is for you to understand that his path would be a 15 feet circle surrounding that stake. Okay? So let's draw a leash. And it's 15 feet long. Okay? So Fido can essentially go in a circle around the stake at a distance of 15 feet. Okay? So that is the locus of Fido's path. And how we would write this, the answer to this problem down, would be, whoops, give me one sec. So let's say the locus of Fido's path is a circle with a radius of 15 feet. So you want to draw the picture, and you also want to write an explanation of what it is. Okay? Let's sharpen my pencil. Alright, so that's example 1. Let's look at another example. So just skip a line. Example 2. What is the locus of points? Three inches from point B. And let's just make this a multiple choice problem. Let's say 1 says a line, 2 says a circle, and 3 says a triangle. So the locus of points, 3 inches from point B. Okay, so make sure you have enough space. If not, use the other side. But I'm going to make a dot right about here. And then I'm going to make a dot 3 inches away, so you can use... I'm gonna draw over things, but that's okay. I don't mind. Let me see if I have room actually. Just gonna make it. Let's change 3 inches to 2 inches. Okay. So I'm gonna get that high. That's how far up I'm gonna go. So what I'm gonna do is use my compass, and I'm gonna draw all the points that are 2 inches from point B. And all the points that are 2 inches from point B is a circle with a radius of 2. Right? Everywhere on this circle you could imagine a point being there, and each one has a radius. Let's draw in a line for the radius. The radius is 2 inches. Okay? So the answer to this would be it's a circle. The locus of points 2 inches from point B is a circle. Let's write this out. The locus of points from point B is a circle with a radius of 2 inches. So whenever you're talking about a locus of points 2 inches away or some distance away from a point, it's always a circle. Alright, let's turn this over. Let's see example 3. What is the equation of the locus of points? Four units from the origin. Okay, so let's go down 1, 2, 3, 4, 5 and make an origin. So I'm going to go 5 up. Well, 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. And the reason why I'm going 5 is because I know the radius has to be 4, so I want to go at least one bigger than that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I also went 5 left and 5 to the right. So 4 units from the origin. Here's my origin. 1, 2, 3. Here's 4 units. 1, 2, 3. Here's 4 units. 1, 2, 3, 4. 1, 2, 3, 4. Plus all of the points in between that. Right? Which ends up being a circle. Okay? Now the question is not just to draw the locus of points 4 units from the origin, it wants to know the equation. Remember the equation of a circle? We did this, so I hope you do. Or I hope you're at least familiar with it. It's x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. So our radius in this circle, remember, is 4, and our center is 0, 0. So h, k in our problem is 0, 0, and our radius is 4. So let's plug it into the equation. We would have x minus h, which is 0, so x minus 0 squared plus y minus k, which is 0 squared, equals r, which is 4 squared. X minus 0 is just x, so we have x squared, plus y minus 0 is just y, so we have y squared equals 16. So this kind of combined two concepts from two different chapters. First, I wanted to make sure you understood what a locus is. Then I wanted to make sure you understood how to find the equation of a circle. Okay? Let's do example 4. A hospital is located at the coordinates 2, 4. On a coordinate grid. The hospital's ambulance service extends for 30 miles. Period. Sharpen the pencil. Write the equation of the locus, which represents the outer edge of the ambulance service area. Okay, so what we need we don't really need to draw a coordinate axis here. What we can do is I'm going to draw the point, just a point right in the middle. I'm going to call it 2, 4 because that's my center, right? And the ambulance service extends for 30 miles. So I'm just going to draw a line and say that it's 30 miles. Now I'm going to draw a circle based on that line that I drew. Because if I were to try to plot that out, it would take up like 2 sheets of graph paper, and we don't need to do that. We just need to write the equation. So now let me draw my locus of points that are 30 miles. So this is a circle that represents all the points 30 miles from my hospital, which is right here at the coordinates 2, 4. So again, our center, which is h, k, is 2, 4, and our radius, which is r, is 30. So we have x minus h squared plus y minus k squared equals r squared. X minus 2, okay, because 2 is our h squared, plus y minus 4 squared equals 30 squared. So my answer would be x minus 2 squared plus y minus 4 squared equals, and 30 squared is 900. That's my answer for example 4. Okay. And I have one more. So we need another sheet with a heading. And this is example 5. Okay. Max's doghouse is 35 feet from Puddle's doghouse. Max's leash extends 20 feet from his doghouse and Puddle's leash extends 18 feet from her doghouse. Draw a diagram showing the areas where each dog can run and the question is, do the areas overlap? Alright, so let's draw a picture of this. Okay? So 20 feet and 35 feet are very big, so let's scale it down to make it fit on our paper here. Alright, so let's make let's make 1 inch equal 10 feet. Alright, so then 3.5 inches would equal 35 feet, and 2 inches would equal to 20 feet, because we need 35, 20, and then 18 feet. So then 1.8 inches equals 18 feet. Okay, so we'll need some space for this. Now it says that the two dogs' houses are 35 feet away, so they're 3.5 inches away. So somewhere like in the middle of your page, you want to make a mark that's 3.5 inches. So I'm going to make one. So if I say this is one of the dog houses, then I'm going to go 3.5 inches away and say that this is the other guy's dog house. Okay? So let's say that this is Max and this is Puddle. And let's actually label this distance. Uh, 35 feet. Then we know that Max has a leash that extends 20 feet from his doghouse. So that's 2 inches. Alright, so I'm actually going to go at an angle. Doesn't matter where, somewhere around him you got to go 2 inches away and make a dot so that you can make your circle with a radius of 2 inches. So right now I'm making a circle and this radius, now I'm not going to say it's 2 inches because I'm going to say exactly what it really is according to my scale, which is 20 feet. So this is how far Max can get, right? That's the path that he can go in. And now Puddle can go in an 18-foot radius path. So I'm going to go 1.8 inches from Puddle in any direction, it doesn't matter, and make a point. So 1.8 inches, if this is 1.5, right here would be 1.75, so it's a little bit more. It's right about here. It doesn't have to be exact. It's got to be close. So now I do a circle around Puddle. Oop, I think I moved. No, maybe not. Around Puddle. Okay. And the radius of this circle is 18 feet. So here they are, 35 feet apart. This guy can go 20 foot around his stake or house, and Puddle can go 18 foot around her house. So this is a diagram showing the areas where the dogs can run. Max can run anywhere in this circle, and Puddle can run anywhere in this circle. So do the areas overlap? Okay, we can say yes, the areas overlap. And I'll draw an arrow pointing at it and maybe even shade in a little bit where they overlap. So the dogs can meet each other right in this area here. They could both be in that area. Okay? So this is how we would solve this type of problem. Now, there's actually, I think, 2 more examples. Let me just double check. I might be wrong. Let's see here. Seconds. Okay, there are 2 more examples. Alright, so on the back, that was example 5. Let's put example 6. Towns A and B. Are 16 miles apart. How many points are 10 miles from town A and 12 miles from town B. Okay, so what we need to do for this one is draw a picture. Let me just check something. Am I going to have room for that next one? Okay. Do me a favor and fold this paper halfway. So you make sure you leave room for your next problem. And right underneath that line, let's write in here example 7. Example 7 is in the diagram below. Car A is parked 7 miles from car B. So we want to sketch the points that are 4 miles from car A and 4 miles from car B. And also label with an X all points that satisfy both conditions. Okay, so and then they give us car A they put about here, and they put car B about there, and they label it car B and car A. So let's look at 6 first. Towns A and B are 16 miles apart. How many points are 10 miles from town A and 12 miles from town B? Okay, so let's say 1 inch equals 10 miles. So then we know that 1.6 inches equals 16 miles. And 1.2 inches equals 12 miles. So they're 16 miles apart. That would be 1.6 inches. So if I put my 0 here, 1.6 is a little more than half. So let's say right about here. So I have A and I have B. I should even draw a line and say 1.6, not 1.6 inches. Even though that's how long it is, I want to put the miles. This is 16 miles. Now, 10 miles from town A, so 1 inch, because remember 10 miles is 1 inch, so 1 inch from town A, right here. So I make a 1 inch radius circle around town A. And I do a 1.2 radius circle because it's 12 miles from town B. So first I got to draw 1.2. That would be right about here. Right? Here's 1, here's 1.5. So 1.2 is almost halfway, but not quite. Okay, so I got my dot 1.2 inches away from B, and I line this thing up. So there you go. You got 10 miles from town A is a circle with a radius. Ooh, we got to draw that in there. We got to draw a line for the radius in, and we have to identify what the radius is. And we got to do the same thing for B. So this is 10 miles, and this is 12 miles. Okay? So here we have it. Now, that's it. That's all they asked us to do for this one. Oh, how many points? Let's put an X on them. 1. So it means, where do they cross? They cross at 2. 2 points are 10 miles from town A and 12 miles from town B. Alright? Now let's look at this one. It's a little bit trickier. So they give us this diagram already made. Alright? And they have this distance here labeled as, well, they don't label it, but the distance they say is 7 miles. Well, according to my diagram, 7 miles is equal to 2 inches. So let's put this down. 7 miles equals 2 inches. So now, the points 4 miles from car A and 4 miles from car B. So we have to set up a ratio to figure out how many inches 4 miles is. So here's what we do. We say 7 miles over 2 inches equals 4 miles over x inches. So we have 7x equals 8. We divide by 7. And x equals, let's see what that is. In decimal, hopefully it comes out to a nice decimal. So I'm doing 8 divided by 7, and I'm getting, it's about, let's say, 1.14. So 4 miles, that's what we just solved for. 4 miles is about 1.14 inches. Okay? So it's a little more than 1. So I go a little more than 1. Let's say right there. Okay? It's a little more than 1 inch from car B. That's going to be my radius for car B. And I go a little more than 1 inch for car A, and I draw circles with those radius from there's my 4 mile radius around car A. And here's my 4 mile. See how I just fudged that a little bit? You can do that. Here's my 4 mile radius around car B. So it says label with an X all points that satisfy both conditions. Well, here's 1. So I label it with an X, and I label this one with an X. So 2 points satisfy both conditions. Okay? That is the end of the examples. Now, I need to give you two problems for your own to check on. I want you to put a heading here. Let's put class period 9, date, my name, and then what we're doing locus, and we're doing lesson L01. So let's call this checkpoint CP1. Okay, here's the first problem. Towns C and D are 12 miles apart. How many points are 8 miles from town C and 10 miles from town D? Draw a diagram and label with an X all points that satisfy both conditions. So let me sharpen my pencil. So that's the question you're going to do on the front, and you're going to use all this space here. So do a nice big diagram, use your ruler and use your compass. Then on the back, you're going to do checkpoint problem 2. Okay, and that's in the diagram below. Car A is parked 10 miles from car B. Sketch the points that are 7 miles from car A and 5 miles from car B. Label with an X all points that satisfy both conditions. And then what I want you to do is fold your paper in half, okay, and write whatever the closest line is. Now fold your paper in half both ways, okay? So that you can see. Alright, now go to the closest intersection of those two lines. So where these two lines cross is right about here. Okay, so I'm going to go to any one of these 4 points and I'm just going to make a little dot so I know about where my diagram is going to be. Now, it says in the diagram below, so right now I'm drawing you the diagram. It's 10 miles from car B. Car A is 10 miles from car B. So I want you to go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. I want you to go 5 lines to the left of that center point, and I want you to put a dot and label that car A. And I want you to go 5 to the right, 1, 2, 3, 4, 5, and put a dot and label this car B. Erase that point, and that is the problem. Okay? So, good luck on that. Now I want you to put these pages in order for a second. Okay? And we got to do one last thing just so everything is all organized in this lesson. Okay. So, there is 1, 2, 3, 4. I have 5 pages total. So what you do is in the top corner, this is 1 out of 5. I turn the page. This is 2 out of 5. This is 3 out of 5. This is 4 out of 5. And this is 5 out of 5. And then when this is done, you hand it in, and that is the end of the first long lesson on locusts.